Hi everybody, my name is Rayna Lunn, and today's screencast will be focusing on an introduction to data analysis. So data analysis is the process of inspecting, cleaning, transforming, and modeling data in order to discover useful information, arrive at conclusions, and support decision-making processes. Data analysis takes place over an 8-step process from start to finish. And these steps are to first define your question, identify your measurement methods, collect the data, scrub the data, model and analyze, interpret, optimize, and repeat. So let's dive right into the first step, defining the question. It's important to begin the process of data analysis with the right question. Your question should be measurable, clear, and concise. It's best to design your question to either confirm or disprove a hypothesis or potential solution to the problem that you're trying to address. It's also important to note that your question may change at some point during this process. However, it's still essential that your question is clearly defined from the beginning. So for the purpose of this screencast, we're going to look at a set of data on grad school acceptances. This list was created manually by a member of the application screening team, and these schools are all HBCUs, which are historically black colleges and universities. So the reason that we're looking at this data is to determine whether or not targeting recruiting efforts at these schools is an effective tool in diversifying the applicant tool for this residency program. So that's our question. And so the second step is measurement. So once you've identified a question that will best address the problem at hand, you must then determine how you're going to measure your results. So this involves choosing appropriate metrics that will best represent your data. The way that we're going to measure our results is by acceptances and denials, and then we'll later break it down more specifically into the reasons for the application outcomes. So I'm just going to give a brief overview on how to go about identifying appropriate metrics in terms of your specific data set. So first we're going to start with the different types of metrics. So in general, there are qualitative versus quantitative metrics. So quantitative data is typically easier to understand. They're numbers that we can track and measure, things that are ranked, counted, or put on a scale. And they're easier to aggregate, extrapolate, and put onto a spreadsheet. On the other hand, qualitative data can be messy, subjective, and imprecise, and it's harder to quantify and measure. But the important thing about qualitative data that quantitative data doesn't offer is that qualitative data answers the why for your question, which can definitely be an important thing to take into consideration, especially when you're using data to make decisions. So the next type of metric is vanity metrics versus actionable metrics. So vanity metrics are exactly what they sound like. They're metrics that are data that can't really be acted upon. You kind of have it just to have it, and it's something just to look at. Whereas actionable metrics can give you an indication of important changes and point you to the areas that you should focus on. But they don't necessarily give you the answer to your problem. They're typically the starting point for identifying solutions to your problem. The next type of metric are exploratory metrics and reporting metrics. Now, reporting metrics are those that you look at on a regular basis to monitor the progress of a project or an organization as a whole. So typically that's a report that you may pull daily, weekly, or monthly that is just a standard indication of the health of a certain program. Whereas exploratory metrics are used to dive deeper into unsolved problems. The next type of metrics are leading versus lagging metrics. So leading metrics are metrics that predict what will happen in the future. I'm going to use a metaphor of a news station. So leading metrics give you the forecast for the week, whereas lagging metrics are historical metrics that show you how you've been doing. They report the news. So they tell you what's happened the day before, and leading metrics predict what's going to happen in the coming few days. The next type of metrics are correlated versus causal metrics. A correlation describes the size and direction of a relationship between two or more variables, while causation indicates that one event is the result of the occurrence of another event. So this is basically a cause and effect relationship, and it's important to note the difference between causation versus correlation. So in general, your metrics shouldn't help ensure that you're on track to achieve your goals. They should be easy to understand and interpret. They should be easy to track on a regular basis, and they should also be relevant to your question and the solution that you're trying to identify. So this means that you may need to change your metrics over the course of a long-term project to ensure that your data continues to meet the characteristics that I just described. So with regards to the data, the metrics that we want to assess are based on the application outcomes that I mentioned before. And specifically, I want to make our metrics the reason for the application outcomes. So in this case, we'll be looking at several different reasons, such as low GPA, didn't return the application packet, not selected for an interview, or declined an interview. All right, so the third step in this process is actually gathering the data that you'll ultimately be working with. So the first thing to note is what data has already been collected with regards to your issue. So you want to be sure that you communicate with key stakeholders to determine what work, even if not directly related to your question, has been done with the data that you want to collect. This will save you a lot of time and just ensure that you're not duplicating work and doubling your efforts. And then the next thing we're going to look at are collection methods. So some questions that you want to ask yourself are, what is your time frame? What factors should be included? What are some non-obvious factors that may impact the question? What resources can you get access to? And do you want to collect quantitative or qualitative data? So I already went into a brief overview between the differences between quantitative and qualitative data. So these are some of the types of quantitative data that you can collect. This can take place during interviews. You can send out a survey. You can collect annual reports. It can be an assessment of a certain department or something like that. It could be a report that you pull from an online database. You could run an experiment or even conduct a study. And these approaches can also be used to gather qualitative data. Just the way that these studies or collection methods are designed differ depending on the type of data you're going to collect. But with qualitative data, something that's unique are focus groups, documental revision, which is basically just a lit review, observation, and longitudinal studies. So the next step is data scrubbing. So data scrubbing is when you detect and remove and or correct incorrect data points within your data set. So the reason why you do this is because dirty data may be incorrect, out of date, redundant, incomplete, or formatted incorrectly. So the goal of data cleansing is to bring consistency to different sets of data that have been merged from separate databases. Maybe they were collected incorrectly. Maybe you pulled it from an automatic report and something went wrong with the automatic pull. But basically, this is just a step that you take in the process to make sure that your data is good to go before you begin analyzing it. So this can be done manually by going line by line or by using formulas, lookup tables, or rules. So since the data set that I'm working with is not too big, I'm going to go through line by line and make sure that the categories I want to look at are all coded in the same way. So with this, I see the category of having a low GPA pop up a few times, but each instance, as you can see, it's worded a little differently. One says GPA too low, one says low GPA, one just says GPA. So I'm going to pick a standard category name and just copy and paste that into each applicable cell. And so this will ensure that each row of data is included in the subsequent analysis. So as you can see here, I'm highlighting all the incorrect data points, and then I won't show this, but I'm basically just going to pick one standard method and copy and paste that into all the highlighted cells. So the next step in the process is the part that we're all excited about, which is actually data modeling and analysis. So there are two types of data analysis methods that you can use. The first is descriptive analysis. So this type of analysis helps describe, show, or summarize data in a meaningful way that makes it easy to identify patterns that occur in your data. So you're probably familiar with the following methods, and so that's just identifying the mean, which is the average, and the median, the mode, percentages, frequencies, or ranges in your data. And pulling out these types of descriptive analytics can just help you easily highlight patterns and have some good working facts to work with. And so the other type of analysis is inferential analysis. So this technique allows us to use samples of big data and allows us to use these samples to make generalizations about the population from which the samples were drawn. So when you're using this type of analysis, you can either identify a correlation, which describes a relationship between two variables. You can use regression analysis, which shows or predicts the relationship between two variables. Or you can conduct an analysis of variance, which tests the extent to which two or more groups differs. So in order to conduct these different types of analysis, there are a lot of different tools available. So Microsoft Excel is what we'll focus on, but the tools listed on the right are tools that you can use to automatically analyze your data. Now, these are often used by larger companies to analyze huge data sets, but some companies also still use Excel and if they have a very strong data analytics team. But today we're going to focus on Excel. So my favorite feature and what I think is the best tool in Excel are pivot tables. So pivot tables are a reporting engine built into Excel. If you know anything about Excel, then you know how painstaking and frustrating crafting formulas can be. Putting together manual formulas to analyze large data sets would take hours on end. I honestly can't even imagine how people did this before pivot came into existence. But now you can create a basic pivot table in 1 to 2 minutes and immediately begin interactively exploring your data. And so once you've created a pivot table, you can begin slicing and dicing your data in so many different ways. And the most important feature that distinguishes a pivot chart from a typical bar graph is your ability to compare more than two variables at a time. So as you can see here, I'm going to first copy and paste the data from the different universities into one tab. And then once that's done, I'm going to make sure everything's formatted correctly and then actually create the pivot chart. So now that the data is all in one place, we'll see here I'm actually going to start to make the pivot chart. So first you'll start off by highlighting all the data points that you want to include in your pivot table, and then you'll just go to the Insert tab, click Pivot Chart, and you can choose to paste that either into a new worksheet or into an existing worksheet. I already had a worksheet with the titles that I wanted, just so everything was easy to understand. So then you get to the part where you get to slice and dice your data. So the two main fields we'll be working with are values and axis categories. So values is what you want to do basically to get your count of whatever data you're looking at. So as you see here on cell A1, it says the count of application outcomes. So that's just basically the number of responses. And so then once you add an axis category, it actually filters those responses out into the different categories. So at first I did the track choice so I could look and see what the responses were based on the types of tracks that people were choosing. And then I decided to slice it a little bit of a different way. And I wanted to see, based on the actual focuses in the hospital, what the responses were here. So I'll just make the font a little bigger so you can see it. And then I'm going to add data labels. So this just makes it easier to see the percentages. So the way that you can change these count numbers to percentages, you right click on the count, this will open up, and then you can show data as a percentage of your column total or a percentage of the grand total. So I'm going to use the column total. And then you can right click sort, and I want to see it from smallest to largest. So I can see which candidate track choices were the most popular out of all the schools together. Basically, you can see here all the multiple different ways to move the data around. There's so many different things that you can do in the pivot table that I could really spend hours on it, but I would definitely recommend just finding a data set you can use, getting in there, making the pivot table, and just start playing around with the different features. And I personally think that that's the best way to learn, is to learn by doing. I'm going to move quickly through a few steps just for the sake of time. So basically what I'm going to do here is I'm going to change the way that I filter the pivot chart. So let's see. I'm going to add another row category. So this time, as I mentioned before, you can use 2 or more variables. So this time we're going to look at 3 variables. So we're going to look at the application outcome, the those category results, and then the actual tracks that the candidates pick. So this way we can see the reasons here why people did or did not actually complete the application process. And then between that, we can look at, of the candidates that did not interview, which tracks did they pick? Of the ones that didn't return a packet, which tracks did they pick? And things like that. And then from here, I'm going to go ahead and just highlight some of the data points that stand out to me within each category. So I'm going to pick the highest one in each category. And that's what we're going to look at. And then based on that, we can see this is for adult emergency, adult critical care, and adult critical care again, based off of various application outcomes. So right now I'm thinking that I might want to go in and deep dive more into the data regarding the adult hospital emergency or critical care tracks and see what results or interpretations I can make after honing on the data. So it's finally time to interpret your results. So the previous step that I mentioned, which was the modeling and analysis, is essential in helping you interpret your data. The visualization of the data that you create through charts and graphs, in this case pivot tables, can help you identify trends, points of concern, areas of opportunity, or things that you may want to explore more in depth. So it's important to note, though, that if your data set is not unreasonably large, you should try to take a stab at interpreting the raw data on your own instead of relying exclusively on the data models. So although your goal is ultimately to answer your initial question, it is important to keep your mind open when interpreting the data. And you probably already have a hypothesis about what the data is going to tell you, but I really strongly urge you not to fall into confirmation bias. So with that being said, some important questions to consider when interpreting your data are: does the data answer your original question? How? Does the data help you defend against any objections? How? And are there any limitations on your conclusions or any angles that you haven't yet considered? And so with this data, one thing that I noticed quickly in terms of descriptive analytics was that the most frequent application outcome overall was that the applicants simply did not return their packet. That was a large chunk of the applicants, over 40%. So the question that led me to think of was, why are people not sending the packets back after we've reached out to them and to express interest in them as a candidate, and why are they not interested in our program? So that's making me think, what about our program is not attractive to this group that we're targeting, which is a group of minority nurses? And so that's something that I'm going to continue to deep dive into the data even further to see what solutions I can come to that new question that I've now come up with. We're coming to the end of our data analysis process. The most important and final step is the interpretation of your data. But step 7, I think, is particularly important, which is to assess and optimize the process as a whole. So data analysis is not by any means a one-size-fits-all technique. The way that data is gathered, analyzed, and presented will depend on the objectives of your data analysis. Therefore, it's very important to make customizations throughout the process. Furthermore, there's always room for improvement, so definitely be prepared to go back to earlier steps and rework certain aspects of the project that you're working on. For example, you may realize 2 months into a long-term data collection that you needed to gather information on an additional metric. Now, you'll then have to go back and correct your collection methods to reflect this change, and then keep this change in mind when you're analyzing your data, and make a note of this when presenting your data to key stakeholders, just to make sure that you're being transparent and that your data is reflecting accurate conclusions that are based on sound data and analysis. So this is step 7, but it really is a step that occurs all throughout your process, but should also happen at the end, just to basically make sure that everything is in order before you present this data, or offer any firm recommendations based on your data. You want to make sure that you've done this in the best way possible, before involving other parties and making decisions that will impact other people. So finally, once you've done that, your last step is to just repeat. So like I said, you times maybe have to go back to the beginning of the process, assess your question, or where I'm at in the process right now is, after making some interpretations, I have more questions. So I'm going to use those questions and go right back to the beginning and go back to my data and come up with some different models and some different ways to slice and dice the data so I can come up with some new solutions. So that's all I have for you today. I definitely want to thank all the listeners out there for taking the time to listen and watch this screencast. I've definitely learned a lot on this journey over the past few months, and I hope that this screencast can either get you started on your journey in learning about data analysis, or if you're not on a journey, it can just pique your interest and realize that analyzing data can be fun, can be interesting, and without a doubt is definitely a very useful skill to have. So this is Rayna Lunn, and I'm signing off.